In today's lesson, we will still be working with the linear function, but just a different form of the linear equation. We have worked with slope-intercept form, which is y equals mx plus b. And now we're going to look at a new form, which is called standard form, which is ax plus by equals c. X and y are still our true variables, and then a, b, and c will be our numbers, our coefficients. So there's just a couple rules for this to be in proper standard form. The front coefficient a has to be greater than 0, which means the leading coefficient is not negative. And then also, all a, b, and c, they must all be integers. So your final answer, if in standard form, will never have any fractions. Here, I just want to make a quick point that there is an infinite amount of ways to write an equation for the exact same line. This line at the right corresponds to this equation, y equals 3x minus 4, that is slope-intercept form. And it is also equal to 3x minus y equals 4, that's in standard form. And it is also the same as this equation, which we will learn in the next couple lessons. Here we have an equation in slope-intercept form, y equals 5x minus 32, and we're going to rewrite it in standard form. So remember, standard form is ax plus by equals c. So in other words, we want x and y to be on the left side of the equal sign. So I'm going to subtract 5x on both sides. This leaves me with negative 5x and a positive y on the left side equals negative 32 on the right side. Now, proper standard form means that the leading coefficient cannot be negative and that there are no fractions. Well, in this case, we don't have any fractions, so that's fine. But if the leading coefficient is negative, to change it, we need to multiply everything in the equation by negative 1. Because if you multiply everything in the equation by the same number, we're not actually changing the line. We're just changing how the equation looks. So this becomes a positive 5x and then a minus y equals a positive 32. And we have now changed that equation into proper standard form. Let's do the same thing in this example. We need to get x and y on the same side. So, because this time x is negative, I'm going to add 4/5 x to both sides. This leaves me with 4/5 x plus y equals 6/5. We need to make sure that the leading coefficient is positive, which in this case it is. However, the goal is also that we only have integers in our equation, no fractions. So instead of multiplying by negative 1, we need to multiply by something to cancel out our fractions. And since we have the same denominator, we can multiply by that denominator. So we have to multiply everything inside the parentheses. And remember, when you're multiplying an integer by a fraction, think about multiplying to just the numerator. So 5 times 4 is 20, so 20/5 x plus 5 times y is 5y equals 5 times 6/5 is 30/5. And now we can simplify our fractions. 20 divided by 5 is 4, so 4x plus 5y equals 30 divided by 5 is 6. So there is my equation in proper standard form. Here's a nice and easy one for you. We need to get x to the left side, so I'm going to add 4x to both sides. So I have 4x plus y equals 43. I don't have any fractions to worry about, and my leading coefficient is positive, so one step and I'm done. There's proper standard form. Okay, here's the last example, writing equations from slope-intercept to standard form, and we have fractions again. Well, let's start by getting x to the other side, so we're going to subtract 7/3 x to the other side. So I have negative 7/3 x and a positive y is equal to 25/3. There are two problems with this. We have fractions and the leading coefficient is negative. So I'm going to multiply everything in my equation by a negative, because that will make my leading coefficient positive. And then I have the same denominator in my two fractions, so I'm going to multiply by that denominator. If you don't have the same denominator, you just multiply by a common multiple. So let's multiply all of these here. Negative 3 times negative 7/3. Multiply negative 3 times negative 7, so it's positive 21/3 x. Negative 3 times y is now minus 3y equals 25 times negative 3 is negative 75/3. And now simplify your fractions. So it's 7x minus 3y equals negative 25. And we could have even done that multiplication easier if you just simplified. If you notice, our 3's would have canceled, but the negative sign would have carried to the 25. And then also, this 3 would cancel, but a negative and a negative made it a positive. What's left over? 7. So, don't forget, get your x and y to the same side, make sure the leading coefficient is positive, and that there are no fractions in your final answer. Now we're going to graph linear functions that are written in standard form. So, instead of using the y-intercept and the slope, like you would in y equals mx plus b, we're going to graph them using two important points. And that is, we're going to solve for the x and the y intercepts. So first, the x-intercept is the point where the graph crosses the x-axis. I want you to think about, what do you know about that point? Any point on the x-axis, what do you know about the value of y? It is always y equals 0. So, in my equation, I'm going to plug in 0 for y. So, 7x plus 3 times 0 equals 21. And now I'm going to solve for x. So here this cancels, and I can divide by 7 and divide by 7. So x equals 3. So that means I have the point 3, 0. That is the x-intercept of my graph. Now let's do the same idea, except we're going to solve for the y-intercept. The y-intercept is the point that crosses the y-axis. So if you think about any point on this y-axis, what do you know about the x value? The y-intercept means that x equals 0. So I'm going to plug in 0 for x and solve for y. So 7 times 0 equals, that's supposed to be plus plus 3y equals 21. This cancels. Now you can divide by 3 and divide by 3. So y equals 7. So I have the point 0, 7 is my y-intercept. So I can plot that point. And now all I have to do is connect those 2 points, and I will have a straight line that represents my equation. So there we have graphed this linear equation by just finding two important points, the x-intercept and the y-intercept. Let's follow the same steps for this next example. So, to find the x-intercept, we have to remember that that is when y equals 0. And to find the y-intercept, you have to remember that is when x equals 0. So, going back to the x-intercept, we need to plug in 0 for y. So negative 3x plus 5 times 0 equals 15. Well, this will cancel and leave you with negative 3x equals 15, which means x equals negative 5. So my x-intercept is the point negative 5, 0. And now for the y-intercept, we need to plug in 0 for x. Negative 3 times 0 plus 5y equals 15. This cancels out, so 5y equals 15 and y equals 3. So my y-intercept is 0, 3. Now I just have to connect these 2 dots and then do my best to extend the line. Now, I think you get the point, so we'll do this one very quickly. If we plug in 0 for y, we're left with 2x equals 3, so x equals 3 halves, which is 1.5. And then for the y-intercept, plug in 0 for x, which will leave you with y equals 3. So to plot those 2 points, on the x-intercept, we'll plot a point at 1.5. And then on the y-intercept, we'll plot a point at y equals 3. And then we will connect these 2 dots and extend our line. So there we have quickly graphed a linear equation finding our x and y intercepts. For our very last example, we have a story problem, and we can write an equation in standard form and then graph using x and y intercepts again. So, the student council is sponsoring a carnival to raise money. Tickets cost $5 for adults and $3 for students. And the student council wants to raise $450. So if they charge $5 per adult plus $3 per student, and they want that to be equal $450. For this example, our 2 variables, adults and students, they can be interchangeable between which one is your independent and which one is your dependent. So I'm going to make students on my y-axis and adults on my x-axis. Now let's see, if I want to make an xy table, well actually it's going to be an adult and student table. We're going to graph finding our y-intercepts. So we want to know how many student tickets would we have to sell if we sell 0 adult tickets, and then how many adult tickets would we have to sell if we sell 0 student tickets. So in other words, if you plug in 0 here, you're left with 3s equals 450, which means that S equals 150. So that is one of our y-intercepts. And then considering the other way, if you plug in 0 for S, you'll be left with 5a equals 450. Which if you divide both sides by 5, it leaves you with it a equals 90. So my two intercepts are the point 0, 150, and this of course is a first, S second, and then my other intercept would be the point 90, 0. I'm going to label my graph and I'm going to count by 20s. So 20, 40, 60, 80, 100, 120. And then counting up, I'll count by 20s as well. 20, 40, 60, 80, 100, 120, 140, and 160. So if we sell 0 adult tickets, we'll have to sell 150 student tickets. And if we sell 0 student tickets, we'll have to sell 90 adult tickets. So those are my two intercepts, and now I can connect those two dots for my graph. So that is my full lesson on the standard form of a linear equation, writing it in the proper form, graphing it using x and y intercepts, and even being able to write an equation from a story problem and then graphing using your intercepts. Good luck with the lesson.